So, hello there. I have a treat for you, have I not? Over the last few days, I've been working busily on an implementation of Model Context Protocol uh, in a way that it's really easy to add to Swift apps. And for me, it was for motivated because of two things. Uh, One was that Cursor actually allows you to add MCP servers to using it to use um, in your uh, where is it, cursor here, in your uh, editor. So there's this MCP section here, and that allows you to uh, to add your own MCP servers. And the other is I found that it was a very good test case for implementing Swift macros. Uh, the reason being, you often see YouTube videos where they implement something in Perl, and they have decorators where they put an attribute next to it, and then it's just implemented. And I thought, well, wouldn't it be nice if we could do something like that as well? And I'm here to show you today that I have achieved it. So let me get right to it. Here's my screen. So I've put it out as on GitHub next to, it's not Swift Mail, but it's SwiftMCP. It is a bit rough still, yeah, but the basics are working. So I want to show this off to you today. So there's a bit of a README. Yeah, there are two ways how Model Context Protocol can work. One is over standard I/O. That basically means that the JSON RPC events are put onto uh, the standard in of a terminal app, and the responses come back in standard out, and it goes back and forth. And there's a sort of more advanced version of that to actually have a independently running HTTP server, and it always says HTTP plus SSE because it means HTTP is where requests are sent via post, and the response for the HTTP post is then the JSON RPC answer. And then there's also the possibility to send notifications from the server to the client, and that is done via a second channel via SSE. And SSE is basically means that the client keeps an HTTP connection open, and if the server needs to send something, he posts these notifications onto this open HTTP stream. Yeah, but that's not implemented yet. So let's focus today on standard I/O mode. And there is a demo, SwiftMCP demo. So let me just show you how that's done. So if you want to implement an MCP server, all you need to do is you'll have to have some struct or class or actor that's sort of your server, and you decorate this with the add MCP server um, decorator. And you should also put in a version, because this version is being reported to the MCP client as the version of your server. And if you don't specify a name, it takes the name of the struct. So this would be calculator version 0.1, but you can also put a custom name here, custom calculator. Then this is what the client sees. And for the individual tools, you just have functions, normal functions, and these functions you decorate with MCP tool. And the magic here really is the MCP tool does some behind the scenes magic so that this function becomes callable Basically, what I need to do is, because there's no NS invocation on Swift, I'm creating a version of this function that can be called with a dictionary. And the MCP server has a protocol. Actually, let's look at this. This is here in the protocols. MCP server has a call tool function that gets generated by the macro that allows me to call a function by name and the arguments. And behind the scenes, then calls the actual function you have here. So it's really, really quite amazing. And there's even some more magic here. Namely, if you don't put anything here, it still knows what the description is for this tool, which is also sent in the tools JSON description. Namely, it's what is here. It basically goes to the documentation comments and extracts this. And also the descriptions for the individual parameters come from here. Yeah, we will see that in a moment. And this way, well, it's a good reason why you would want to add this information, because that is useful to the LLM that wants to call this, because then it knows what these parameters are doing. So that's really all there is to it. Yeah. The MCP command here of the demo is essentially the main. Yeah, it just creates this instance of this calculator, and at the moment we still need to do this manual loop. But in the future version, I'll essentially just say calculator run standard IO loop, or calculator run the HTTP server, and then that will do it for you. But it's interesting to see basically how it works. Yeah, we're doing an endless loop, and it reads a line. So that means text, JSON, RPC commands need to always just be one line and be terminated with a new line. And so once we get such a line, we decode the JSON RPC request from it. Yeah, it's basically a certain structure. And we give that to our server to handle. Yeah, and the calculator, through decorating it with MCP server, gains these functions of the MCP server protocol. And one is to handle the request and the response from this handle. So at the moment, we're supporting initialize, notification initialize, list of tools, or performing a tool call. And the response from that, if it's not nil, it's codable. Yeah, so codable. That means I can encode it with a JSON encoder, and again turn it into a string, and then just print it. That means I put it on standard out. And what's important also is to flush it. And I found that apparently for some reason we needed to also have this sleep that improves things. And if at any point there is an error, yeah, decoding or encoding, then I catch that, and at this moment then the loop ends. Yeah, and that's all there is to this. Yeah. Let me show you how this works in action. There's a nice tool from it's called MCP Web Inspector. From under Model Context Protocol. You can install this on Macs. Yeah, and then on the command line in the project folder, you just say mpx Model Context Protocol / inspector, and then the command by which to execute the binary that processes the standard in. Yeah, and in my case, I could either write the executable, but I found it's also just as well works with Swift run, because if you do Swift run, yeah, then I'm here now in this waiting for the response. Yeah, and of course, because this is not valid JSON, it would exit. But if I do that with the npx, yeah, Swift run, now it runs and it creates this localhost 5173. And so if I open this in my browser, I get this nice testing interface, and you see command is Swift, argument is run. So I can click connect. Then it does actually the running of the well, compiling and executing, and now we are connected. You see there's a green connected, and we already have it knows that there's tools available, so I can list the tools. Yeah, you see here the commands. Yeah, it sent the tools list, and the response is all the JSON description essentially from all the tools, with types, with the description that comes from the comments. Yeah, so for example, let's look at, this is the subtract. Yeah, subtract we have here in our demo. Yeah, is basically all this information. Well, the data type comes from here. Yeah, and the description comes from here. So it says a number to subtract from, b number to subtract. Yeah, and these are all the commands that are available. So for example, there's the ping command. If you run this, yeah, you get back Pong, yeah, because this is basically, it returns Pong. Or if you have the greet says Oliver, yeah, hello Oliver, because it returns hello Oliver. And even for example, if you do something with numbers, yeah, let's say 2 times 4 is 8, yeah, and here you can see that uh, the input schema is b and type number, yeah. But if you call the tool, is the cool tool, it passes the argument as int, yeah. So it correctly deals with the different data type, and that works even with an array. Yeah, here you have a one that requires an array, and the Web Inspector has the functionality to add like multiple items here, so that you have something in the array, yeah, and then you can run the tool, yeah, and the result is, in our case, I'm just concatenating with join, so I make strings out of it and join them with comma, and that's exactly what you get here, yeah. So actually, let's say that I don't want to be disturbed. There's also another thing. If you have a default parameter, like for example here, you have a default parameter that's 1, yeah, for the divide function. It even says so here, defaults to 1. So if I say, okay, number to divide at 5 and run it, yeah, it still works. On the other hand, if you do say a multiply and you don't put in the parameters, yeah, you can actually say cool parameter a is expected type int, but got string with value nil. Yeah, so actually this message is slightly wrong. It should say that the parameter is missing altogether, because you see it's not in here in the arguments. Yeah, so that's basically it so far. Yeah, it's a start. Yeah, there are other kinds of things that Model Context Protocol supports, like there's, for example, resources where you can expose certain documents via a custom URL, with a custom URL scheme, and then a path. Yeah, I could start supporting that also via macro and prompts. Yeah, I'm thinking if it's prompt, it's just a string. So if I decorate maybe add MCP prompt string, then that would allow MCP to query that. And there's some other things, but you see, I'm quite proud of this, because the uh, the macro things are quite really nice. Yeah, and this is sort of, I've been always kind of jealous of PHP that they can do this. Like for example, for tools that are to be exposed to the function calling or tool calling from LLMs. Yeah, you could do something like that for that as well. It's essentially model context protocol is more or less the same as this, but it goes one step further because it also says, okay, OpenAI just has the spec and you have to implement it somehow on the client. And MCP basically says, okay, and if you have a client, this is uh, how you put it into a server, yeah, so that you don't have to put the code for executing the, the tool calls locally into the client, which you don't have access to, because if it's like the cursor um, uh, or the okay. So yeah, that's it for now. So I hope you like it and see you next time. If you have any feedback, leave it in the comments. Thank you very much. Bye bye.